Interactive interview on design control, verification, validation, and traceability. Interviewer, welcome to this session. Let's start by understanding your experience with design control processes for medical devices. My questions will cover concepts, documentation, traceability, verification, and validation with examples. Be honest and detailed in your answers. 1. What is your understanding of design control in medical device development? Why is it important? Ideal answer. Design control refers to a structured process mandated by standards like FDA 21 CFR 823 and ISO 13485 to ensure medical devices meet user needs, regulatory requirements, and safety standards. It involves phases like planning, design inputs, outputs, verification, validation, and design transfer. It's crucial because it reduces risks, ensures compliance, maintains traceability, and ensures that devices are safe and effective when released into the market. For example, while working on a syringe project, we adhered to FDA QSR to document every step, ensuring traceability from inputs to validation. 2. Can you walk me through the design and development process you followed for a medical device project you've worked on? Ideal answer? Certainly. For a syringe project, 1. Planning. Created a design and development plan outlining activities, deliverables, and timelines. 2. Design inputs. Defined user needs, e.g., 5 millionths capacity, biocompatibility. 3. Design outputs. Produced engineering drawings, material specifications, and packaging design. 4. Verification. Verified outputs using dimensional inspection, biocompatibility testing, ISO 993, and pressure testing, ASTM D775. 5. Validation. Conducted usability tests with healthcare professionals and simulated injection scenarios. 6. Design transfer. Ensured seamless handoff to manufacturing with validated processes and training. 7. Traceability. Maintained a design traceability matrix linking inputs to outputs, verification, and validation. 3. How do you define and manage design inputs for medical devices? Can you provide an example? Ideal answer. Design inputs are specific, measurable requirements derived from user needs, regulatory standards, and risk management activities. For example, during a surgical instrument project, one design input was the instrument must withstand 200 degrees Celsius for sterilization. To manage inputs, I conducted stakeholder interviews to understand user needs, referenced applicable standards like ISO 7153-1 for surgical instruments, used tools like a requirements management system, e.g., JAMA software, to document and track inputs, ensured every input was testable and linked to traceability. Mark R4. What is the purpose of a design traceability matrix, DTM? How? Ideal answer. The DTM ensures every design input is traceable to its respective outputs, verification, and validation activities. It's critical for compliance, risk management, and demonstrating control over the design process. I created DTMs in Excel and ALM tools. For instance, in a syringe project, Column 1, Design Inputs, e.g. biocompatibility. Column 2, Design Outputs, e.g. ISO 10993 compliant material specifications. Column 3, Verification, e.g. biocompatibility testing reports. Column 4, Validation, e.g. clinical evaluations. This matrix was reviewed during audits to show alignment across the design lifecycle. 5. How do you differentiate between design verification and validation? Can you provide examples? Ideal answer, verification. Ensures outputs meet inputs. Are we building the device right? Example, pressure testing a syringe to ensure no leakage at 300 psi. Validation. Ensures the device meets user needs. Are we building the right device? Example, simulated use testing by injecting liquid into a model to validate dose accuracy. I always maintained a clear distinction to ensure regulatory compliance during audits. 6. What standards do you commonly refer to for verification and validation activities? Ideal answer, ISO 10993, biocompatibility testing. ISO 11135, sterilization compatibility testing. ASTM D4169, packaging integrity testing. ISO 62366, usability engineering. ISO 14971, risk management. During a surgical implant project, we validated biocompatibility per ISO 10993 and performed fatigue testing as per ASTM F2077. NASTR 7. Can you describe a challenging scenario you faced during design verification? How did you resolve it? Ideal answer. In a syringe project, during pressure testing, we observed leakage at 310 psi, slightly above the specification of 300 psi. After root cause analysis, we discovered variations in plunger material. Resolution. We worked with suppliers to tighten material tolerances and updated the assembly process. Retesting confirmed compliance. 8. How do you ensure compliance with regulatory requirements during design validation? Ideal answer. I ensure compliance by 1. Reviewing applicable standards, e.g. FDA guidance, ISO 13485. 2. Creating validation protocols aligned with user needs. 3. Conducting testing in representative environments. 4. Engaging real users for usability testing. 5. Documenting results meticulously for audits. For example, in a surgical instrument project, we validated sterilization efficacy per ISO 17665 through real use simulations. 9. Scenario. If during validation, healthcare professionals report difficulty operating the plunger of a syringe, what steps would you take? Ideal answer. 1. Investigate user feedback to identify the root cause, e.g. excessive force. 2. Conduct usability tests with a larger group. 3. Update the design, reduce plunger resistance. 4. Revalidate usability with the updated design. This iterative approach ensures the final product meets user expectations. 10. What role does risk management play in design control? How do you incorporate it? Ideal answer. Risk management is integral, ensuring potential hazards are identified, mitigated, and controlled. I follow ISO 14971 to conduct hazard analysis, identifying risks, e.g. needle detachment in syringes. FMEA, assessing severity, occurrence, and detection. Risk control, implementing controls, e.g. reinforced luer lock design. This ensures device safety and regulatory compliance. Have you participated in regulatory audits for design control? What was your role? Ideal answer, yes. I prepared documentation, ensured traceability, and explained design verification and validation processes during audits. For a CE marking audit, I presented the DTM and validation results, demonstrating compliance with EU MDR. 12. Can you explain human factors testing and its importance in design validation? Ideal answer. Human factors testing evaluates user-device interactions to minimize use errors. For example, during a usability study for a syringe, we observed clinicians to ensure plunger resistance was intuitive, preventing dosing errors. And 13. If a verification test fails, how would you handle it? Ideal answer. 1. Analyze test data to determine the failure root cause. 2. Update the design or process. 3. Conduct risk analysis to assess the impact. 4. Retest with updated criteria. Thank you all for joining this interactive interview session on design control verification and validation. I hope the PPT helped you understand how these processes ensure product quality and compliance. It's amazing to see so much interest in mastering the traceability matrix and its real-world applications. Design control is a game changer in product development, and paying attention to verification and validation can make all the difference. Keep learning, stay curious, and I can't wait to connect with you all again.